With number 3 here, this is an extension of working in your radical or square root unit here in Algebra 2. We have a situation where we have the time t. It's the period it takes a pendulum to complete a full cycle, and we give the definition. So this is a classic physics definition where capital T equals the product of 2 pi times the square root of L over g. We define g as acceleration due to gravity at the 9.8 meters per second squared. L is your pendulum length in meters, and then T is your, of course, period in seconds. So they want us to answer a few things here on this. They want us to solve the equation for L, just leave everything in the original terms. And then if we have a pendulum with a given length, what is its period? So that's just going to be a substitute and solve. And then, of course, we have given a particular period. We'll go backwards. We'll figure out what our length is here. So with part A, I'll go ahead and start that. We have A, T equals 2 pi, and then we have the square root of L over G. So first things first, you always want to, of course, isolate that particular square root. And so I'm going to divide both sides by 2 pi. And that's going to be our first move there. Move an arrow here. So we have t over 2 pi, and we'll have the square root of L over G. And we can now we have our square root isolated. We can actually square both sides. That was a lousy 2, sorry. 2 and 2, okay. So I like to group things in parentheses. That's merely a preference. And if we square the fraction on the left, we have t squared over 2 pi squared. And we can, of course, drop the radical on the left. Whenever you square a radical or square root, it simply drops the radical. So you have L over G. Now I'm just going to do it a step further. T squared, on the bottom we'll have 4 pi squared. Remember, both the 2 and the pi are squared. And there we have it. Keep going here. And whenever I have a fraction or even both fractions separated by an equal sign, I apologize, I want to go ahead and cross multiply. And I'll do some additional algebra to isolate that L. So when I cross multiply here, I have t squared times g equals L times 4 pi squared. And ultimately, to isolate that L right here, that's this guy right here, we're just going to divide both sides by 4 pi squared. There you have it. So we have L equals t squared times g over 4 pi squared. Excellent. So there's L in terms of t, g, and 2 pi. Or I should have just said pi. I'll fix that. And if we have a pendulum that has a length of 2.5 meters, what is its period? So this is using the original equation, right? T equals 2 pi 2 times pi whole square 2.5. Make sure you have the meters, which we do, 9.8. And I didn't say how to round, but maybe round to the nearest thousandths on this, 3 decimal places. And that's typical of Algebra 2. Okay, so 2 times pi, that gives you 6.28, dot, dot, dot. And then we'll just go ahead and square root the 2.5, divide out by 9.8. So I'm just doing the math here. So I have the 2 pi, and I'm going to take that by the fraction that has a square root. Ultimately, I get 0.505. And that's in seconds. Now for part C, we know that L equals t squared times gravity over 4 pi squared, the constant 4 pi squared. So given, let's say they gave us 3.91. Okay. I'm just using our equation from part A, and I'll go ahead and put in our numbers. So 3.91, we square that, times it by 9.8, we'll get roughly 149.82338. That's actually exactly what's in the calculator. And then 4 times pi squared gives me 39.4784176. So if I take the previous answer, divide out by that 39, I get roughly 9.5. Yeah, 3.795, and that would be SI units of meters. All right. Thank you very much on this one. See you in the next problem.